Good afternoon. I'd like to thank everyone for joining us today for the Build Alberta Virtual Education mini-series. For those of you that attended yesterday's session about embodied and operational carbon, I hope you enjoyed the presentation and the excellent breakout that followed. If you didn't catch that session, it will be available on demand shortly. My name is James Wyatt, the Programming Manager for the BuildX series from Informa Connect. Firstly, I'd like to thank our sponsors for this week's event. Vectorworks, the series title sponsor, session sponsors Intuitive, Gasonic, and Vectorworks, and our commercial sponsors, Intertech Windows and Doors, and TM Signs. Without them, this mini-series would not be possible, and I invite you to check out their websites and social media profiles. Now, you may submit your questions in the question box throughout the presentation, and these will be viewable by our speakers. Please use the same box for technical or platform-related questions, and we'll gladly assist you. Additionally, there will be a Q&A breakout session on Zoom directly after this session at 1 p.m. Mountain Time for 15 minutes. You may join this session to ask questions or continue the conversation through the chat, audio only, or video. I will share information on how to join this breakout at the end of this session. Lastly, I'd like to introduce you to one of our speakers to kick off today's session, and that's Neil Barman, Product Specialist at Vectorworks. Neil is an architect in British Columbia and a product specialist with Vectorworks Canada. He provides workflow consulting, software training, and support for clients across the country. Neil has a deep understanding of Vectorworks, enjoys empowering others to become efficient and create more with software. He is also a co-designer of Victoria, which is BC's first LEED Platinum home. Without further ado, over to you, Neil.
Thank you, James. So today, I'd like to welcome Sarah Barrett and Luc Lefebvre. They will be presenting a session on real-time audit of 3D models using data visualization. Now, there's a lot of information to cover during the session. So the main presentation is a recorded video featuring Sarah and Luc. Sarah is also with me today, and we will both be available during the presentation via the question panel to answer any questions you may have. We will also be available during the breakout session afterwards. Also, please note that if you're a member of a professional association, you may be able to submit this session as a self-reported learning unit. Please refer to your jurisdiction's continuing education guidelines. And with that, I would like to introduce Sarah. Sarah brings more than a decade of experience as an architect and a graphic designer, as well as professional expertise in the field of parametric modeling to her role as Senior Architect Product Specialist at Vectorworks. In addition to serving as an architectural expert and BIM specialist for the company, she helps create best practices for Marionette, the integrated algorithms-aided design tool in Vectorworks. She leads webinars and workshops on a variety of industry topics and develops materials to help customers improve their workflows and design processes. Sarah received her MArch from the University of Michigan and her BA in Architectural Studies from Brown University. Thank you very much, Sarah, for joining us today.
Thank you, Neil. I'm happy to be here. And I just want to reiterate, as Neil said, that this will be a video, but we will be available to answer questions in the chat during the presentation, as well as in the Q&A session afterwards.
Super. So with that, let's begin the presentation.
Hello and welcome to this webinar. My name is Luc Lefebvre, Product Marketing Manager for Vectorworks. With several years of experience in the architectural field as an architect and BIM manager, I always try to find new ways to gain efficiencies in the design process, and more specifically with BIM projects. With new functionalities we implemented in the last 2 years in Vectorworks, I'm excited to show you new workflows that will help you gain efficiency in both your internal process and in the collaboration realm of BIM projects.
Hi, my name is Sarah Barrett. I am a Senior Product Specialist at Vectorworks. Using data-driven workflows has also been a passion of mine for a long time. I'm always trying to find the most efficient way to do things. So using BIM in architecture seemed like a logical step for me. I'm also passionate about teaching others to use data-centric tools. So I hope this webinar helps you gain insights on how to make your BIM model do more for you.
Today's presentation is a real-time audit of 3D models using data visualization. We hope that with this presentation, you will gain knowledge on how Data Manager and data visualization can be used for a quality assurance workflow and to enhance your workflow by minimizing data discrepancies, reduce errors, and increase the quality output of your building information models. Today's learning objectives are: explore various sources of data and determine how to use them with your model for optimal results. Learn what data visualization is and how it can be used for data verification. Discover the benefit of data mapping to improve your open BIM workflow with IFC data, and identify best practices to maintain consistency with your models. In general terms, data is a collection of facts such as numbers, words, measurements, observations, or a description of things. When speaking of data for a digital model used in architecture, landscape, or any kind of discipline involved in the design of buildings, it's not too far from this description. I wanted to start this presentation in giving you an idea of the types of data that you may use in the course of designing a building. Some of them may be obvious to you, but as building design is becoming more and more automated, I think it is important to gain the most basic knowledge first. I grouped data in two distinct parts, qualitative and quantitative. Quantitative data means that you will be able to locate and qualify any types of objects. Any type of objects you draw or model. XYZ coordinates is a way to locate objects in relationship to a universal system. A vector will give you the length, a polyline will give you a surface and the perimeter. Prisms will give you a volume. And as you progress and assign real building elements types, you will start qualifying what the geometry represents. Not only the walls will have a geometric quality, but they can be defined with components. Those components can be qualified with materials. Examples of qualitative data is the location of building elements in the project. This is how objects are organized in the model, which is really important if you want to collaborate with consultants on BIM projects. I'll come to that later. So each object will have various sets of qualitative data. A wall, for example, will have materials assigned to each component. The assembly may have a fire rating, an acoustic rating, a function such as shear walls, bearing wall. These are called object parameters. IFC property set is a type of data used and actually a very important aspect of BIM collaboration. IFC, or Industry Foundation class, is mostly known as a file format, but it is actually more than a file format. IFC property sets allows software to organize the data for building elements, making it possible to communicate between platforms. Each software has their own internal ways to organizing a BIM model. This format allows those digital models to come together in an organized way. I'll come back to this in a bit more details later. As I described on the previous slides, the data can really be anything you want. You can qualify any objects the way you want. We call this a record. If the data is not included in the object parameters, you can add that data with a custom record. Think of it as a piece of information that you attach to an object, and that information becomes part of it. As a designer, you can model anything with any types of geometries. For example, you can easily model something and make it look like a building. For example, solid modeling, push-pull surfaces, NURBS. Those are the types of geometry that will give you just that. Designing with data for an architect means you qualify the geometry. You will use actual building element objects to create the digital model. In this illustration, you see that walls, slabs, doors, windows are used to not only visualize the project in 3 dimensions, but also to automate drawing creation, generating elevations, sections, etc., is one benefit you get from modeling with 3D geometry. You say, okay, I can do that with simple 3D geometry, and I do not need to do all of the work and create an actual building model. Well, here are other benefits of designing with data. Automatic creation of schedules, takeoffs. This is where the qualitative data really starts to pay off. When using a door object, the door will have a geometry, but will also contain information such as the frame type, materials, finish, door hardware, fire rating, etc. All of this can be automatically reported on a spreadsheet and will be updated when a change occurs. There is a great gain in efficiency when doing it this way. Okay, so maybe you know or already doing all of this and asking yourself, how can I leverage this data to help my process? There are so many possibilities to really take advantage of the data. You can analyze the model, or perhaps you want to use the data for validating or verifying the data. This process is great for ensuring that you meet the expectations of the client, or even in making sure your models meets a set of standards, and even perhaps create diagrams to better communicate the design intent. We will spend some time with Sarah on how data visualization can support this. And finally, data will give you the opportunity to collaborate with the project team. This presentation focuses on these last 2 points: how to use the data to analyze and verify your model during the design process, and to ensure the quality of the data before the collaboration process with external stakeholders starts.
So what is data visualization? Data visualization is displaying graphically the underlying inherent information of an object. This information can be displayed as singular values, such as a 1-hour wall rating versus a 2-hour wall rating, or as a range of values, such as glazed area of less than 5 square feet to 5 to 15 square feet to greater than 15 square feet per room. I want to show a very simplified example of data visualization because I think it's a fundamental aspect of BIM, even in a very simplified form. In this document, I have rectangles. These rectangles can be anything, represent anything in the drawing. If we were drafting, we would have to use some sort of manual label or legend to describe what these rectangles represent. One of the biggest differences between drafting and BIM is that with drafting, we apply this information manually in our drawings. But with BIM, we apply the information to the object and extract that inherent information in our drawings. This makes the process of creating drawings and representing our designs much less manual. I can convert these rectangles to BIM objects simply by attaching data to them. With data attached to them, they are no longer ambiguous rectangles, but specific objects. I have attached a custom record to these rectangles. A custom record, as Luke mentioned, is a simple table of information, a table that I've created and attached to the object. You can see that this record has several different types of data formats: text, checkboxes, dates, numbers, and dropdowns. All of these can be used in a custom record to better represent the data that you want to convey. With this record attached, I can query that data in a schedule. I can tag that object to display its data in a label, and I can use data visualization to show that data graphically in the drawing. With the object selected and viewing the Data tab, you can see the record values of this object. You can also see how the different data types are formatted in the record. So now that we know these objects have data, let's look at how we can visualize that data. This menu up here allows us to manage data visualization. I can turn on an existing data visualization by selecting one. When I select one, you can see that all the objects in the drawing area change. Some are red, some are green, and others have been grayed. So let's look at what this is showing. If I go to edit this, you'll see the criteria is all objects. An important thing to note is that data visualization can be applied to objects within groups, symbols, and plugin objects. I'll show examples of this a little later. The display criteria that is selected is the either/or field of the custom record attached to our rectangles. When you're creating a data visualization like this, when you go to select the parameter that you want, the different values of the parameter that already exists in the document will show in the window below. Once you have those values, you can apply fills, line weights, and textures to each value. At the bottom of the window, you see a checkbox that says Draw All Other Objects Grade. This means that any object visible in the document that does not match any of the applied criteria will show up as grayed. You can see that these three rectangles are gray, and this tells us that they do not have our custom record attached to them. Now, if I select one of these grayed rectangles, and remember, it's selectable even though it's grayed because it's still a selectable layer and class, it's only grayed because of the visualization. I can attach our custom record to the object and it will get the fill color that is associated with the default value. Now, if I change that value in the record, again, the object will change color. Hopefully you can see that this is a great way to not only visualize, but also validate the data that is attached to your objects. This record that's attached is an example of qualitative data, as Luke mentioned earlier. When attaching data via a record, it's important that you only attach qualitative data, unless you're using data mapping, which Luke will discuss a little later. The reason for this is that when you model an object, the quantitative data is already inherent in the object. It's automatic. So you can visualize this quantitative data using data visualization as well. So let's demonstrate this by creating a new data visualization. We'll click on the menu and select New Data Visualization. Next, the Define Criteria button. Because we're going to look at quantitative data, we're going to more stringently define our criteria. We're going to filter by type and look for rectangles. You can see that these are all the object types currently in the drawing. When we select rectangles, you can see that there are 41 rectangles in the document. If we uncheck symbols, then we only have 11 rectangles. We can also add more filters, such as by layer or by class. So let's make sure that we are only looking at rectangles that are on the data demo rectangles layer. We'll click More Choices, select Layer, and then Data Demo Rectangles. We still only have 11, so filtering by layer may not have been necessary at the moment, but it's important to set up these things with the appropriate criteria from the beginning so that as the file grows and changes, these visualizations remain correct. This is a good practice, not just for creating data visualizations, but whenever you're working with data, be it with creating schedules, tags, etc., the correct criteria is key. So now, if we want to find the quantitative or inherent data of our rectangles, we need to choose Objects Using Function for our display criteria. If you look at the list of possible functions, they mostly refer to an object's size or location, the information that comes from simply creating the object in the file. So we'll stick with area. And you can see all of the areas for the rectangles in the document. If we go to color settings, you can see that we have auto color checked for both pen and fill, with the start color and end color matching. That means that the colors will range in a full rainbow. When we select auto color, you see that rainbow applied automatically. When we click OK, all the rectangles will change color based on their area. There are a lot of colors here, and it's hard to remember what each one means, so it's not a very useful data visualization as is. So we're going to change it to make it a little simpler and a little clearer. We can do this by applying colors to ranges of values. So let's edit this data visualization. And instead of choosing by values, we can select by ranges. When you choose by ranges, you don't have the existing values to guide you. This is because ranges should encompass future values or standard values that you're already aware of. Our largest value was somewhere about 2,000 square feet, so we'll use that as a guide. When we add a value, we can set the lower and upper bounds for each range. So let's make each range value 500 square feet. I can apply the attributes and change the colors later, but first I want to set up my ranges. It's important that range values don't overlap. So the gap in the values will depend on the size of the range. So this can be a tedious process, but it's important to know that you can save your data visualizations for use later. You can either save them in your user folder, or you can save them in a template file so that they will always be available from the start of the project. When doing ranges like this, you already have an idea of the significant range values. So these values are usually based on real standards. And as we're doing now, these values are pretty arbitrary, just to show you an example. Now that we have our values, we can auto color, but let's change the settings first. Let's turn off the pen auto color and then make our range a little closer in color. This way it makes the change in color have a little more meaning, where the more yellow means larger and the more red means smaller. So now we have our ranges set up. We can see how our rectangles stack up. This type of data visualization can be very helpful while designing. For example, say I'm laying out spaces or dividing an area into smaller areas. With this data visualization active, I can draw rectangles and see immediately how their size compares. As I change the size, you can see the rectangle change in the color range. This can be really helpful when trying to keep room sizes within certain areas as you're working on a program. It's also important to remember that although these are just rectangles at the moment, they can be converted into more intelligent BIM objects like spaces. Just because your end result will be a BIM model doesn't mean that these quick and easy tools can't be useful and help you further your design. So now let's look at some more examples of data visualization and how you can use it with BIM objects. So this file that I'm opening up now is a renovation project. So there are existing, new, and to be demoed objects all coexisting in this file. It's important to keep them organized. So they are classed by their status, as well as having custom records attached to them in order to keep their information in line. This first data visualization verifies that new and demoed objects are in the new and demoed classes. Verifying this makes sure that objects display correctly in the drawings created from the model. It also makes it easy to see the extent of renovations even as you're modeling. There is a similar data visualization that checks whether a custom record is attached to objects and what the value of that renovation status within that custom record is. The way this file is set up, this record needed to be attached to every building element, which was very easy to just select all and attach the record at the same time. So you can see that everything in the model is visible, showing only the reference markers, grid, and sidewalk are grayed because they don't have the record attached. There's also data mapping in place in this file to automate the values of the record based on the objects class. But Luke will talk more about data mapping later. There's a class validation data visualization here that isn't particular to a renovation workflow, but is really helpful in any workflow. It is a check as to whether objects are in the none class. If the none class is your active class while you design, you might end up with objects in that class, but you should have either separated them as you were going, or you're going to need to separate them at some point. So when this is turned on, it shows only the objects that are in the none class, so you can change them accordingly. Here you can see objects that are grouped, and those groups are in the none class. Another great object to use for data visualization is the space. The space is an object that delineates a room and acts as a repository for information. Spaces are great for containing data, working with program, and producing diagrams. Here are the spaces for this file. The building is pretty open, so there aren't that many, but they are useful for calculating area. Here's a data visualization that shows the glazing area ratio of each space. You can see that this information is pulled directly from the space object, and it's shown in a range. The values in the range are percentages. So the bathrooms, for example, have 0% glazed area. The second story offices have between 3 and 6%, and that large first floor open area has between 9 and 12% of a glazed area ratio. There's also a semi-transparent texture that is applied to these colors, so you can see some definition below them. So you have lots of options on what data to show and how your objects can look, not only when you're designing, but also in your drawings. Here you can see a floor plan that shows the demoed and new construction using different line types and line weights. There's a data visualization applied to the viewport, one made specifically for plan views, and it can be applied to any viewport, so you don't have to worry about coordinating your drawings manually. You let the data do the work for you. When data visualizations are used in a viewport, they can also produce a legend that can be formatted. Here on this sheet, you can see the same data visualization in a detail plan and another in a detailed demo plan. Because you can control the graphics, you can get the look you want and still have data-driven drawings as opposed to manually drafted drawings. Data visualization allows you to see the data in your model, not only when you're designing, but also when you're producing your drawings. So it can be used both as a design tool and a presentation aid. When it comes to BIM though, there's even more that can be done with data.
You heard this many times. The I in BIM is the most important aspect when speaking of building information modeling. As we discussed earlier, information or data is both quantitative and qualitative. This means geometry and information is necessary to support all processes involved in the life cycle of a building. Some processes may require different sets of data. We are most familiar with the efficiencies you gain internally during the design process, but many processes need to be supported during construction and for facility management. Each process required a specific set of information. For example, during the design process, we are most familiar with the coordination aspect, which is called clash detection process. This process requires the geometry, and it must include the most basic organizational data, which is used to locate each object within the project. This includes space objects, stories, and many more. During the construction, the contractor may want to create a schedule or maintain a cost estimate. These are the 4D and the 5D processes. After the construction, the owner may want to manage the building operations or assets. For example, assets management requires a specific set of data called COBE, Construction Operation Building Information Exchange. Therefore, it is important to determine the BIM project requirements at early stages of project. This can be done in various formats. It can be determined by contractual obligation, which in this case, it is important to understand exactly what the owner intend to do with the digital model. We recommend that a BIM execution plan be created to set the specific goals and to establish the requirements. This is often omitted and can be a cause of dispute or litigation. Knowing the type of information needed and what process it needs to support is critical in the success of the project. One of the requirements you will establish with a contract and/or a BIM execution plan is the level of development. Let me give you a quick overview of those. A building information model level 1 or LOD 100 represent the information at a basic level. Parameters like area, height, volume, location, and orientation are defined. Note the importance of location. As I mentioned earlier, this information is critical in the organization of a BIM model. This information is typically given by a space object in the stories in the file. Level 2 or LOD 200 add building elements such as walls, slabs, doors, windows, but only requires generic information. So wall components, for example, are not required. Note that location and orientations are. This means that these LOD are incremental. And a space object will provide a relationship between the various building objects. So for example, a door will know that it is inserted in a wall and is adjacent to a specific space, and that the wall is located on the 3rd floor, etc. Again, really putting the emphasis on the organizational aspect of BIM. When a level 3 or LOD 300 is required, the model will typically include additional information qualifying each and every building element with exact precision and will include assemblies and various types of data needed to support the project requirements. I did not include all LOD for this presentation, but LOD 400 is to support the construction processes, and LOD 500 is to support the facility management processes. So in the case that the project owner wants to use the building information model for facility management process, the LOD requirement will be 500. And an example of data that will be required for that level is the COBE data set that I mentioned in the previous slide. So why am I telling you all of this? Well, in the almost infinite amount of information you can attach to any 3D object, one important thing must happen in the software in order for the collaboration process to go smoothly. I talked earlier about IFC. This is how the magic happened. In the IFC workflow, or the IFC workflow organizes that data so that you can send the information required by the project. The graphic may be a bit small here on this slide, but you can see that standard objects has an IFC designation. These are called IFC property sets. They are essential for the BIM collaboration process to happen. The data mapping is what makes this process work. And this happens for the most part in the background, allowing you to freely design without thinking too much about it. But in some specific cases, you may want to customize a set of data or information that is required by the project requirements and isn't included in the standard. There is an inherent complexity to all of this, but I will try to break it down for you. We learned a lot about the various types of data and how you can view it with colors as you are designing, so with the data visualization. Now let's look at how you can organize, automate, and connect various types of data. Combined with data visualization workflow, this will really make your day. If you remember earlier, I showed you 3 types of information that are qualitative. The object parameters are integral to each object type. You can access them by editing the object itself or through its style. Any custom records can be added manually or automatically mapped to any object type. These 2 types of data are used internally in the software, regardless whether you are collaborating or not on the BIM project. The IFC property sets are by default mapped onto each object type, and this mapping is used for exporting to the file format for proper coordination of information in the BIM process. The data mapping is managed through the data manager. The data manager has 4 components. First, you can customize, save, and call default mapping at the top. This can be useful to share custom mappings between coworkers or workstations. I really want you to see and understand what the default mapping looks like. Each object in your file is listed on the left, and each standard object has default data mapping. Typing the name of the object like wall, and in the middle you can see the mapping. By default, the mapping contains the object parameters and the IFC data set. The way I can automate or assign a data or a record is by adding a new data set to the specific object or by mapping it. Custom records and IFC property sets can be mapped this way. Let me find the status and phase record I created and map it to the wall object. Now you can see that the record appears along with the IFC and object parameters. I'll come back later to discuss what data sheets is on the right-hand side. Let's select wall and look at the data pane. You can see by default, all data sets that are mapped. IFC data sets are used in the exported IFC file for the collaboration. I'll come back to that. Let's apply what Sarah showed you with data visualization and look specifically at the status record that I mapped. Once mapped, the record will show accordingly in the data pane. This will allow me to directly access the specific set of data and assign the data and confirm the changes that are made as I design. Remember that this record is now mapped to only walls. If I want to use the same record on other object types, you must map the same record to them. I'm showing you doors here, but you can also map records by class and by symbol name. You can follow on the screen all object types I mapped the record to, and applied the data. Here is the final result. I wanted to give you one more example. Say I wanted to verify that my doors and windows fire rating are correctly assigned based on the wall rating. Even though with my various objects has predetermined field for the rating, I decided to create a custom record just for that. So here you can see the record has the 3 object types in corresponding value or corresponding rating value that I can match. I have mapped this record the same way as before using the data manager. So now you can see the record is showing for all 3 types of objects. Additionally, I created 3 data viz sets, which will allow me to verify if the correct data was assigned properly to the object. With the multiple data viz option, I can color my object and do a quick quality check on that model. So here I'm selecting the 3 data visualization set. And here you can see how I can now navigate to different areas of the model and change or assign the correct data to each of the objects. And you can see that the color of the door rating and the wall rating are matching. And if they're not, then you can update that data directly in the data pane. This workflow is great, and what I showed you so far is great for your internal process because you can customize it to fit your own workflow and assign the data that is important to you to achieve what you need to for your internal process. There are 2 more things I wanted to touch base on. One is data sheets, and the last one is IFC mapping for the collaboration workflow. First, let's talk about data sheets. I mentioned this in previously when discussing the data manager. Data sheets are kind of a data template that you create to organize and make all of the information you need available in the data pane of the object info palette. But it also allows you to group any data fields from any source of data. So it means that you can combine any of the object parameters, custom records, and IFC property sets in one data sheet. There are standard sheets for the wall objects. For example, we provided this default BIM wall sheet, but you can create your own data sheet with the data manager. The example shown here is a data sheet that organizes the data required for each BIM LODs. You can use separators, rename the fields if you need to, and organize all data you need to access on this sheet, to access them on the sheet. You can see the data fields added to the sheet are both from the custom record and IFC data. The separators gives you or the person creating the model a cue for what information must be present at each phase. This can be useful when it comes to ensure the BIM object or the BIM project requirements are met before you export the model to your consultants. You can be creative with these sheets. You could use them in a more traditional way for verifying data by phases of design instead. This is another way to make your workflow easier when working with so many components and in a more complex process, such as building information modeling. As promised earlier, let's see how data mapping works and why it's important when collaborating using an IFC workflow in IFC file format. As previously discussed, IFC stands for Industry Foundation Class and is mostly known as a file format, but it is actually more than a file format. Exporting an IFC project means that the data of that project is organized properly so it can work with files created in other BIM authoring tools. To make this process successful, each object modeled must have a related IFC property set. And in order to the export to work, there is a data mapping assigned to each object. I call it IFC mapping because this is a specific mapping for IFC as opposed to a direct mapping of records like we saw earlier. Before showing you how to map this data, I wanted to show you the model exported as an IFC project and look at how the data is exported and organized. With the help of Solibri, I can show you this. When the model is exported, it is exported as a tree. From the site to the building and the discipline, and also by the stories. Each one of these entities have a specific set of data that comes with it. Then each object types have their own specific set of data. From its identification, which could be, for example, the wall style or tag, the locations such as the floor, its height and the XYZ coordinates, its relationship to other objects, and finally, additional property sets. Note that the property sets you currently see do not show all of the mapping we did within Vectorworks. For example, I don't see the fire rating or the status and phase information assigned to the wall. As you can guess, I did this on purpose, so I can now show you how you can ensure that the custom data you created is successfully transferred during the IFC export process. Back to the BIM authoring software, Vectorworks. And let's take a look at the mapping. First, you can see that the data for the fire rating and status are in fact assigned to the wall. But if you look at the actual IFC property set, this shows you what information is actually mapped for the IFC export process. And look closer to the wall, common P set, you can see that the data from the record is not mapped to the IFC data. And the same with the status and phases record. So let's add these sets to the IFC mapping with the data manager. First, we'll add the mapping to this, for the status and phase record. Because there is no equivalent IFC data for this, I will add the entire record as a custom IFC P set. After it's added to the object, then you can assign where the information is taken from. So in this case, I want my IFC file to get the information I assigned from the record. This is simply how the information is pushed from the custom record to the IFC record. Then, of course, we need to repeat the same process for all object types that needs to receive this type of information. And lastly, you can see or verify that the mapping was successful directly in the data pane. The last mapping I want to show you is for the fire rating data. This one is a little bit different because a field from the wall object is already designated to receive the information. But in our case, we decided to use a custom record instead of the standard field of the object, or the standard field the object offers. As you can see, the wall common P set has an existing mapping, but it points to the standard object style data. For our custom record to map to this field in the IFCP set, you must add it to the current mapping. So using the complex formula, you will tell IFC to look first at the standard object field, and if empty, then to use the value from the custom record. You can do that with a complex formula. Now that I have added these values to my IFC mapping, I can verify if my actual IFC project is exported correctly. You can see that the fire rating is now reading the correct data, and that the status and phases record was exported and is shown as a separate tab on the information pane. You can see that the IFC mapping was added to all of the relevant objects I mapped using the data manager. I realized that this workflow might be a bit complex, but one of the goals I had for today was to show you how you can really make use of the data one model includes, in that you can really push the process as far as you want. I'm hoping that after this webinar, you understand better how data can be utilized in a lot of different ways, and that any object can be qualified with any types of information that is used for your process. Data is not only for BIM, and you can use it the way you want. Lastly, data visualization is really powerful, and combined with the data mapping, it can really help your firm be more efficient and provide quality models and documentation to your clients.
Well, that was great. Thank you very much, Sarah.
Sure. And thanks to Luke.
Yes, indeed. Yeah, the topic is so interesting, and as you demonstrated, so easy to get into, and then you can get so much from it. So we do have a number of questions that came in during the session, and I saved a number of them so that we could address them afterwards, because I think everybody would appreciate hearing the answers too. So I'll get right into those. So here's one of the questions. How much time should we set aside for a process like this? And how often should this process be undertaken in a design process, from schematics through to contract documents?
So this is a process that does take a lot of time up front, but you end up saving a lot of time in the long run because it's something that can be carried forward into other files via template files. And the more you do it, the faster it will be to do it, and the more you will get out of it in all your projects down the line.
Good. Yeah, very true. Very true. Okay, here's another one. Can you discuss reporting or scheduling of IFC data on the drawings?
So you can definitely use schedules to audit IFC data. We demonstrated showing data visualization with IFC in order to validate it, but you can just as easily create worksheets that show your IFC data, and then you can change that data, update it in the worksheet, and have it pushed to your objects.
Good. Okay, let's see. Just checking through the questions here. Yeah, here's another one. That's a good one. Are there any sample files that illustrate the use of data visualization tools?
Yes, there is a file that we showed in the webinar of, it's a Greyhound bus station, and that is available on the Vectorworks University, which is university.vectorworks.net. And as well as another file that has data visualization is the High Tour. And those are both in the sample file section of the university.
Yes, good. Okay, let's see, here's another one. Oh, this is interesting, yeah. Could data visualization be used for creating content?
Yes, in some ways. You can create diagrams using data visualization. It doesn't necessarily generate
geometry because it is simply a way to visualize existing data of an object. But it is a great tool for creating diagrams and other things that work well in presentations and informative drawings. So content in that respect, yes.
Yeah, for sure. Yeah. Let's see here. Here's another one. Is there a way to show data associated with an object, like Revit using the tag function?
Yes. So similar to Revit, Vectorworks has a tool called a data tag tool, similarly named, easy to find in that way. It pulls data directly from an object, and one of the cool things about it is completely customizable graphics-wise. So you can create the graphics exactly how you want it to look, but have it pull specific data from an object. So when you tag the object, you get a tag that looks how you want it to look, but is fully coordinated with your object and is a part of a BIM workflow, which is nice.
Mm-hmm. Yeah, I love using the data tag. It's amazing how versatile it is. Okay, let's see here. Here's another one. Will Vectorworks include objects with settings, fire rating, etc., or do we have to customize objects to include this info?
Certain objects do come with built-in data based off of their what they are, their quantitative data. But things like fire rating are not built into walls necessarily, but there is a place in the wall, like the data tab of the wall has a place for you to enter in a fire rating into it, and it would be part of the process of creating a particular wall style, because the wall styles are completely customizable, and since you can add that data, it makes sense that you would then have to add the fire rating for it as well.
For sure, for sure. Okay, it looks like that's all the time we have for questions here, but we'll head over to the breakout session in a bit. I'll let the organizers take over from here. Thank you very much again.
Thanks,
yes,
Neil.
thank you.
Thank you. Sorry, Sarah.
No.
I want to say just a quick thank you to Neil and Sarah, and obviously Luke for his involvement in that presentation. Thank you both as well for sharing your expertise and insights during that quick Q&A afterwards. And also thank you to Vectorworks for making this session and the series as a whole possible. If you did miss part of this presentation and would like to watch it again, or think that one of your colleagues or one of your peers should see it, the recording will be available on demand. So after the event, you will receive a thank you email with a link to your registration. You can share that email with those colleagues or peers, and then they can register themselves to watch the session at their convenience on demand at a later date. So as Neil and Sarah kind of alluded to, we'll be now going to the virtual breakout session on Zoom. You can join the speakers and our other attendees there. You can ask more questions. I know we have a couple of unanswered questions ready to go, and you can get involved through the chat, through audio only, or on video. As you'll see, there is a link now on the slide video for the Zoom breakout. If you're going to join us, click that link now. There is also a link in the resource list. So there's two different ways of finding it. Please do click it now, and you'll be connected to the Zoom meeting. The link will disappear shortly. So again, if you're going to join us, click it now. Thank you again for watching. Click the link, and we'll see you in the breakout.